So far we've done volume, where you know the base and the shape of the base and you know what the cross sections of it look like. This time we're going to take an area on your graph and we're going to rotate it and figure out the volume of the solid that's generated using that method. And the first part of it that we're going to do is called the disk method, and then we're going to build off of that using the washer method. So this video is about the disk method only. And the formula to find the area of a solid like that is going to be the integral from a to b of pi r squared times dx. And I wrote below, in case you were wondering where this comes from the formula for the volume of a cylinder, which is pi r squared times h. And in this case, the h is our dx, the change in x, the delta x is what it represents. So let's do an example. So my first example, we have the curve y equals square root of x on the interval 0, 4. We are going to revolve this line around the x-axis, and we want to find the volume of the solid that's created. So first thing you should do on this type of problem is draw a picture. And on these, I think it helps to draw a picture if you know what it looks like. So hopefully you remember that the square root of x, it should be 3 by the way, it's kind of like a sideways half parabola. Looks like that. And we're looking at the area that is shaded from 0 to 4. So I'm going to shade that in like that. So this is my shaded area. We actually already know how to find the area of that. You just find the integral from 0 to 4. However, in addition to having that area, this is actually going to be rotated. And if you rotate it, it looks kind of like this. It looks like this thing on the right. So it's kind of like a sweet potato half or something like that. All right, so now we have a visual of it. Let's go ahead and find the volume of it. And remember, I mentioned that the volume is going to be the integral from a to b of pi r squared times dx. So now we need to figure out what the a and the b are. Those are the easy part, actually. And the hard part, which is what is that r? So I will give you a little bit of background. The reason this is called the disk method is because if you were to take a cross section of this thing right here, the cross section of this would actually just be a circular shape. It would be a disc. This would be the next one that we're going to do. The cross section actually is a washer. And this disc is going to be, you can think of it as like a circle that has a radius of a certain point. This radius is not going to be the same everywhere. You can see that from the picture. Like at 1, it's going to be a lot smaller than it is at 4. So what we're going to do instead for our radius is we are going to do it in terms of x. And actually our radius is going to be the height of this function, which is the square root of x. So we're going to get our integral, and our limits of integration are just going to be 0 to 4. We're doing our x values here, of pi times my r squared times my dx. That's my height of this entire thing. By the way, the height in this one is sideways, so it's whatever your change in x is. So we end up getting the integral from 0 to 4 of pi, I'm going to pull the pi out front, times x dx. And I'm going to just let you evaluate that on your own, but you do end up getting 8 pi in the end. I do recommend just leave it as 8 pi. You don't need to multiply it out unless you really want to. So if you print out the notes, you'll notice I skipped over example 2. We'll do that one together in class. So right now we're going to find the volume generated by rotating this region bounded by square root of x, y equals 1, x equals 4. And we're going to rotate it around the line y equals 1. So first thing we're going to do is draw a picture. Now, this is going to look really similar to the previous one that we had with one exception. So the big exception here is that your area is only going to start at y equals 1, and it ends at x equals 4. So our shaded area is going to be this part right here. We are rotating it around this line y equals 1, that's right here. If we were rotating it around the x-axis like we did in the previous one, that would actually involve the washer method, which we'll talk about in just a minute. So, sorry the quality of this picture isn't as good as the previous one. I had to use a different applet for that one. So you can see though that it's almost a cone shaped. It's the same type of shape as before. It still has a circular cross section, meaning it's still a disc method thing. The only difference is that the radius of this one is definitely going to be a little bit smaller than the previous one. So we have to account for that smaller radius. So again, we're going to be doing the same formula, pi r squared times dx. This time, you'll notice that my x value, my x values start at 1, not at 0. So be careful about that. If you were wondering how did I get the 1, like other than just looking at the graph, you get that by solving the equation 1 equals the square root of x. You don't get it by plugging in x equals 1. Just keep that in mind. We're solving for, we know that y equals 1, so we're solving for x there. So that's my x value. And then it goes till 4, of course. So the radius of this is going to be a lot smaller. So each of these cross sections here needs to take into account the fact that we started at 1. And it is this area right here, that length right there. That length is going to be the square root of x minus 1. It's different depending on what your x is. Actually, it's at 1, it's 0. At 4, it's going to end up being 1, and then you have everything between. So we do need to take this into account. It's square root of x minus 1 squared times dx. Now, you're welcome to do this by hand. I actually have done it. I did it by hand on my paper, but I actually don't recommend it. Oops, I forgot the pi. I also want to warn you, I do this all the time. You can see I just did it. Every time I do a bunch of these problems, I almost always forget pi at least once. So just check it carefully as you're doing it. Feel free to evaluate this on your calculator. I'm totally fine with that for this one. And when you do that, you should get that it is I'm going to write approximately equal to 3.665.